In our study of simple harmonic motion in classical mechanics, we naturally came across Lissajous figures. Jules Lissajous was a French physicist in the 1800s that studied harmonic motion extensively. He created his figures by bouncing a beam of light off of mirrors that were attached to tuning forks set at right angles to each other. Lissajous figures arise when you have harmonic motion in orthogonal directions, which we can express mathematically like this, where A and B are the amplitudes, omega 1 and 2 are the angular frequencies of the harmonic motion, and phi is the phase difference between them. The ratio of the frequencies and the phase difference is what determines the shape of the figure. If the ratio is a rational number, the figure retraces the same path forever, but if not, we see some other rather interesting behavior. As a homework problem, we were asked to produce plots of some of these figures, so I wrote a quick Python code so I could plot them with any parameters I choose. Here's a plot with the frequencies equal with no phase shift. And here's the same frequencies but with a phase shift of pi. This one is still the same frequencies but with a phase shift of pi over 2. When the ratio changes, we get more interesting effects. This is a 2-to-1 ratio. This is 2-to-1 with a phase shift. This is 3-to-1 with a phase shift. And here we have a 3-to-2 ratio, and here it is again with a phase shift. These are really interesting. Now let's see what happens when the ratio is irrational. This is a plot with a ratio equal to the square root of 2. As you can see, the graph doesn't trace its own path anymore. As we let time increase, we can see that the plot will eventually cover every point in the square. Notice the sharp edges we get from a combination of curved lines. These figures are neat to see, but Lissajous didn't have Python, so I wanted to make these figures mechanically. So I got out my precision do-it-yourself home optics kit. I glued some tiny mirrors to the ends of some tuning forks, and I set up the experiment in my lab. Here you can see the laser bounces off the mirror on the first fork, then off the second one, and then gets projected onto the wall. The forks were very sensitive to the weight of the mirrors, so I tried several times to get good results. I'll play some slow motion clips of some of my best figures. In these first few clips you can see that the ratio of frequencies was very irrational. This next attempt produced some really nice figures. You can kind of picture a 3D object rotating. This last attempt gave us our best figures. Thanks for watching. Hope you enjoyed it.